Okay, so today we're going to finish up chapter 11 on inheritance. Short chapter, just 2 parts. Okay, on Friday, we're going to cover chapter 12, which is also short, on recursion. Okay. Recursion can be a little bit confusing sometimes, so if you can get a chance, I'd take a look at it before class starts. Would be helpful. Okay. So next week, we have on Monday, we're going to be doing a review. And on Wednesday will be the next exam. Okay, so there is one problem in chapter 11. There weren't many. We did problem 1 for lab yesterday, and we're going to do 2 today in class. So problem 3 is the only homework assignment in this chapter. Okay. Any questions before we get started? Okay. So today we're going to talk about one of the other big concepts in object-oriented programming. That's the idea of polymorphism. Okay, so polymorphism can mean a couple of different things. The first thing it means is that we can define a local version of a function in a subclass. That when we have a member of that subclass, that's going to be the one that's going to get fired. Okay, so it allows us to specialize even further. The whole idea of creating a subclass is a specialization of a superclass. That specialization can include making new versions of the code. Okay, it's true in most programming languages that if there are multiple candidates to take, you're going to take the most local one. So, for example, in our code, if we have a global constant set and we have a local variable in a function with the same name, it's a local variable that's going to be accessed. Okay, so and we've done this already with the init function. We haven't termed it that way. Okay. The other thing that polymorphism means is that if you create a function that takes an object of type superclass, then it will also take objects of a subclass of that superclass. Okay, so we're going to do an example with mammals and dogs and cats. So if you write a function that takes a mammal, then if you have an object of type dog or cat, that function will take it as well. Okay, the reason it can do that is the dog or the cat object have all of the attributes and all of the functions of the superclass, because a dog is a mammal and a cat is a mammal. Okay, doesn't work the other way. If you have a function that's designed for a subclass, then it may not be able to take a superclass because it's going to get confused if there's the new stuff's not there, the added stuff's not there. Okay, so that's the idea. And one thing I will say is that unlike some languages, Python does not allow function overloading. I know if you've done C++, you've seen that before, where you can have a function with this two different functions with the same name, but with a different number of parameters. Okay, you can't do that in Python. The reason being because Python is interpreted, it's going to remember the last thing that it sees. It has no way. C++ compiles the whole thing and can create a dictionary of what all the different versions are. Okay, so we can't do that at all. So no function overloading, but we can do polymorphism of renaming the functions. Okay. So if you have questions along the way, yell or something. And make sure you put in comments coming up to the test. I haven't been, I often don't. It should have at least your name and what the program's supposed to do. Okay. Any problem that is an object-based problem, an object-based programming problem on the exam, you don't have to test for validity and you don't have to do a try for it. Okay. Just for this test, we're focusing just on the objects. Okay. If there's a dictionary problem or a set problem, then everything still applies. Okay, it's only on objects that we do this. Okay. If you do enough objects, they're going to become pretty boring, pretty straightforward. So that'll be the goal coming into the exam. Okay. So we're going to start here with a class mammal. Okay. This class, you should get in the habit of following a procedure when you do things so you don't have to think about it twice. So I'm going to do the init function. I'm going to do the accessors. I'm going to do the mutators. And I'm going to do any additional functions or other functions that the problem may call for. Remember the one we did with the circle, we had an area and a circumference. Okay. I put those in right away so I won't forget. I then go through it and put the stuff in there. The book always says mutators first. You can do whatever you want. Just don't switch it up. There's no reason to remember two different ways. Okay, do the same thing. Be very ritualistic in your coding, and you'll be good. Okay? Everything takes a self. Okay, and in this mammal case, all we're going to store, and I'm on page 566 if you're keeping up, is species. Okay, this is kind of a forced example, as we often do in class. So we're going to let a self dot underscore underscore species be equal to species. Okay, that's all we need for that. In this case, there's not really an accessor, and there's not really a mutator. Okay, so we can you can leave them in there if you want to remind yourself, or you can get them. This is a weird example. The other functions here are going to be some print functions. Okay, so we're going to have a function called show species. It only takes a self. And this is like an accessor, but it's instead of returning, it's going to print something. Okay, so it's going to print out I am a, followed by the self dot underscore underscore species. Okay. So it's a specialized function that just does that. Okay. And we're going to have one more function here that we're going to make multiple versions of called make sound. Just like so. Okay. And this one's going to print out what they're calling a generic mammal sound of grr. Okay. Again, it's a forced example just so we can see what happens with the main classes and with the derived classes. Okay. So I'm going to put a comment here that I'm ending class mammal. Okay, just so I'm straight as to what's going on. You have to end that before you get into your main. Okay. We can test this and say that M is equal to mammal. That's going to fire up the init. So I have to give it a species. We're going to call this pig, let's say. Okay. So I can then do a print. No, I don't need to do a print. It does a print for me. An M dot show species function. And do an M dot make sound function. Okay. I'll go ahead and print just to. If we had other animals, we'll be able to see what we're doing here. And I'm just going to print a line. Okay. So if I didn't typo something, which you never know, I should be able to print out. And we have I am a pig, the pig goes grr, which is not correct if you're, a small child, you would know that. We're going to do it. Okay. So, questions so far? This is just a basic class definition. Yeah, nothing weird. Okay. I'm now going to make a dog class that extends mammal. Dogs are mammals, so we're okay with that. Again, I need to, I've got a different list of things since this is a derived class. Okay, I'm going to call the superclass init function, and then I'll have an init, and then I'll have accessors, and I'll have mutators, and I will have other functions. They don't all have everything, but at least you get the idea here. Okay. So this first call, the superclass init, happens in the init. Okay, so I guess you could also, if you want, just. Well, I guess it could be separate. It's not separate in this case, but it could be separate if you different. Okay, so we're going to create this one first. Kind of combine this. Okay. And in this case, dog has no additional data attributes. All it's going to do is redo the make sound. Okay, so it's a little bit of a forced example, but it has to have the underscore underscore init underscore underscore. All it can do has to take self, and it takes nothing else. Okay, so I have to call the mammals init function or the mammals constructor in C++ terms and I have to send it to species, but since it's a dog, I know what the species is, right? So I don't have to mess with it, okay? So it's going to call mammal, underscore, underscore, init, underscore, underscore. Okay. Every time you have a subclass, you're going to do this. It's going to send self, it's going to send the species dog. Okay. That's all it does. Okay, we have no accessors, we have no mutators. Okay. We could, or we could change the species, but we're not. Again, it's good to put them down there. You can leave them, you can get rid of them, whatever you want. As far as the other functions go, we're going to make another version of make sound. It only takes a self, and it's going to print, you guessed it, woof, woof. It's like being in kindergarten, isn't it? We should get our rugs out and have nap time after this, and have some juice or juice box. Anyway, so the idea here is if the calling object is a mammal, it's going to run this make sound. Okay. So if in this case, when I call make sound, it calls the function on line 12. Okay. But if I were to create all of this, copy it. Got a dog now. Okay, so instead of it being a mammal, I'm going to let D be a dog, and a dog takes no parameters. Okay. So now when I say D.show species, okay, there's no local version of show species, so it's going to go up to line 9. The self here is going to refer to this dog object, and it's going to print out I am a dog. Okay. But when I get to line 38 with the D as the object, which is a type dog, it's going to look here and see, oh, there is a sound, a make sound here. So this is going to run the make sound at line 25 and say woof, woof. Okay. So again, that's the polymorphic effect. Okay, so let's run this. What? Okay, what have I done to it? Okay, so now we have I'm a pig, I'm a dog, we changed it. Okay. Questions on how this works? Okay, do one more example, because the more you do, the easier life gets. If you're bored of it, then you're probably ready for the exam. We do a cat, which also extends mammal. Okay, so it's going to have the same basic structure. For the init, it has no additional data that we're storing, but it is going to call the mammal init function. Note that if you had included this as like an import, instead of being in the same file, you would have to put whatever the file name is, dot name of the class. Okay. For the exam, you can do it all on one file and it's fine. Same for the homework, even if it says something different. Okay, so we need to send it a species. Okay, she was a question. Will pickle be on the exam? No pickles on the exam. And there's cheering in the streets probably, because pickles confuse people. I don't understand. But they do. Yep, no pickles. She was happy. No pickles. Okay. So once we have this set up, again, the only other thing we're going to do is we're going to make a new version of make sound, which just has self. Okay. Getting the self here. Everything needs self. Okay, and this one's just going to print. That's this, again, copy it all. Paste it. I'm going to do a cat. Cat. C.show species and a C.make sound. Okay, run this one. And we have now a cat, a pig, a dog, and a cat. Okay. Each one runs their most localized version of make sound. Okay. Now, if for some reason I didn't put this function in, there's no obligation to do that. When I run it now, it's just going to gurr like the animal. Yeah, Sam.
Okay, so that was another thing I was going to ask was, for instance, like in this class, if you wanted to have a print statement in your init, you just have to do self dot and then the variable name from the parent class, or you have to do like mammal dot and then the function name?
No, if it's defined in the superclass, it's defined in the subclass.
Okay, so,
Okay.
So like for cat, if you kind of get cat,
Yes.
print out the thing.
Yep.
I guess you have a variable when you have access to it. Okay.
Yeah. So, but I have access to species, so I could have a set species and be able to change it to something else.
Okay.
Yeah, which wouldn't work in this example because we're kind of tying that into the different objects or the different subclasses. But yeah, you could do that. That's certainly a thing.
Okay.
Okay. Remember, a cat is a mammal. All the things that the mammal has, the cat has. But it can redo the functions if it needs to. Okay. Questions about this idea? Okay. So the book is going to get to something now that we've already done. That's the is instance. We've used that for our preconditions, right? Well, they're going to use it here to make sure that we don't send something incorrect into our functions. Okay, so, and again, it's like a precondition in that sense. Okay, so they're going to do that by kind of forcing a bad example on us here. It's not going to work. So they're going to, it's not there, it's outside of main. So they're going to define a function called show mammal info. It takes a creature, whatever that happens to be. It's then going to do with that creature, the creature dot show species. And it's going to do a creature dot make sound. Okay. Now, this is perfectly okay if I send it something that makes sense. Okay, so I could say show mammal info on M and show mammal info on D. That's going to work just fine. See, no problems. Okay, but if I would send it on something random, they send I am a string, which is interesting. If you do that and run it, you're going to get an attribute error. Okay, because our objects have a show species, but our string does not. Okay, so if we want to make sure this is not a problem, okay, we're going to have to change our function that takes the object to make sure we have an object of the correct type. Okay. So for that to work on this show mammal info, let's do the following. We're going to have to say if is instance, okay, we've used this before, the object creature and the type here, if we would have to put in, if this were stored in a file that we're importing, we have to put the import name, that file name, but it's not, so we can say mammal. If it's a mammal, Okay. Then we can do this and we're good. Else we would print not. So if we do this now, this should give us the not a mammal, which it does. Okay. So to make sure, you can't just test for the errors, you have to test for what works too. So if I do a show mammal info on M, which is of type mammal, it should work as well. And it does. Okay. Remember, M was a pig, so we're good there. Now the first one, this gave us the correct not a mammal. The second line, so 58 gave us the error, 59 was fine. Okay. But remember, polymorphism says I can send it a version or a subclass, an object of type subclass. So I should be able to do here both a D and a C. So if you ask the question, is instance creature mammal? If it's a dog, it's going to say yes. If it's a cat, it's going to say yes. Okay, because they derive from it. And see if this works. Now we have our dog and our cat. Okay, so that is instance. It's going to be useful to make sure we're getting the right thing. Okay. Okay. So questions on that? Okay. So let's take a look. We're going to start with the first part of what we did for lab yesterday on the employee. And then I'm going to go ahead and do homework problem 2, which is ShiftSupervisor. Okay. So again, you want comments, which I'm not going to put. So to do problem 2, you have to do the employee class from problem 1. My class employee. This is what yours should have looked like. Okay, no parentheses. Okay. So again, I need an init. I need the accessors, mutators, and I need the other functions. Define underscore underscore init underscore takes the self. Okay. In this case, we have a name and we have a number. Okay, so I'm going to set self dot underscore underscore name equals name. Self dot underscore underscore number equals number. Okay. If you don't understand why I'm doing that, it's a really good time to ask. Okay. Here's where I'm setting up what was on my UML diagram or what was in the problem. Okay. And UML diagrams are pretty ingrained in my mind, and I probably even on a test, if I don't have to, I would jot one down just so I know what I'm doing. I don't forget stuff. Okay. They're that useful, I think. Okay. So that's the name, that's the number. According to the problem, we need an accessor and a mutator for both. Okay. So do the accessors. Define our get. And again, if you do mutators first, like the book, doesn't matter. Just don't switch it up. I mean, I don't care, but there's no reason to remember 2 things. They take just a self. That's going to return self dot underscore underscore name. And define the function get number. And these should happen quick. Again, do them enough that they do happen quick. Return self dot underscore underscore number. Okay, that's all I got there. Mutators need one of those each as well. So we're going to do the set name, which is going to take a self and a name. Okay, and then we're going to let, in this case, we're going to let self dot underscore underscore name equal name. Okay. The mutators do exactly what the init does. Okay. This one in particular, if this were something we needed to check the range of, like it had to be greater than 0 or greater than 1,000,000 or whatever it has to be. Okay. If we check it there, we need to check it in the mutator as well. Okay. The same rule should apply. We're not doing that yet, but just keep that in mind. Okay. In particular, I tried this morning to make sure, and it doesn't work, and I understand why now. In C++, it's common to call the mutators from within the constructor. Okay, so in the init, just say set name, set number, right? You can't do that in Python because since it's interpreted, when the init hits, it is not yet seen those other two functions. Okay, so you can't do that. So you just have to replicate the code. Okay. And in the same way, and it's not much to it. But I mean, I guess if there were complex structures there, complex ifs there, we would have to redo those. Okay. Self, take a number. Self dot underscore number equals number. Okay. In this case, there are no other functions, but it's worth having that in there. Okay, so then I can end class. Okay, so then, I mean, you can always run it at this point. And it doesn't do anything, but if there were an error, it would tell you. Okay, so for example, if I would have left that off, it still didn't complain. Well, I guess it didn't do it good. Oh, I guess that makes sense. So there's no point in doing that because we haven't. Again, think what Python does. It's going to say, okay, yeah, I know where this is now. It's not going to check. Okay, so you do have to do something. Okay, so in def main, I have to do at least. I'm going to say E is equal to employee have to have a name, number. Okay, you do that. Call main. Good enough. You didn't do anything, that's fine. Now that would have given us an error if there were a problem up here. Okay. So to test this out, here's the plan for this. And again, I would literally make notes in my code just so I can keep myself straight. We're going to test the init function. We're doing that there. Okay. We're going to do this on two different ones. We're going to say this is the employee init function. Okay. Then we're going to test the accessors. Okay, we're going to print e dot get name, comma e dot get number, and parentheses there. Okay, so if this prints out, then I'm good. Okay, so now I'm going to test the mutators. And for that, I'm going to do an e dot set name, Bob. And an e dot set number 345. Okay. Copy this down. And that should be all the tests that we did. Okay, run this. It was Alice 1, 2, 3. Now it's Bob 3, 4, 5. Okay, we're good, right? So the next thing we need to do, all of that was in problem 1. We should have done this online. So for problem 2, we have to add, instead of the production worker, which we did in problem 1, a ShiftSupervisor. Okay. So we're going to have a class ShiftSupervisor, which is going to inherit from employee. So in that one, again, we have to call the superclass init. Okay. We then have to initialize other things, other new data. Okay. We then have our accessors. We then have our mutators. Okay. And then any other functions that are. Okay. So the first thing we have to do here in our init. Okay. So these really happen the same thing. These are both in the same init function. So it's hard to make a comment out of. Okay, so we have definition, underscore, init, underscore, takes a self. Okay. We have to take all of the data that the employee needs, which is name and number, we have to add what the shift supervisor needs, which is a salary and a bonus. I must spell bonus with 2 U's. I don't know why. Okay, so that's what we have there. Okay. To take care of the name and number, we have to call the employee dot underscore underscore init underscore on self name number. Okay. We then do the self dot underscore underscore salary. Salary. Self dot underscore underscore bonus. Okay, that should set things up for that. For the accessors, we don't need the accessor for the set name and set number. They're already there. We're not going to change them. Okay, but we do need a set, sorry, the gets first, accessors. So we don't need the get name or get number. They're already there. We need the get salary. Makes itself. Function. We're going to return self dot underscore underscore salary. We need the def for the get bonus. That's itself. And it's going to return self dot underscore underscore bonus. Okay. Mutators, again, it's all formulaic. We're not really having to think about it. This just is what it is every time. Okay, so we have a set salary, which is going to take a self and a salary variable. That self dot underscore underscore salary. If there were restrictions imposed up here, there should be restrictions imposed down here. There's not. We're just assuming they know what they're doing. A dangerous assumption. Set bonus and a set self. Bonus. Self dot underscore underscore bonus equal to bonus. Okay. We have no other functions. Okay. And all of that is going to then in class shift supervisor. So we've tested this part. And we can copy this more or less. We're going to do the same things on the next one, except we're going to add a little bit to it. Okay, so we're going to copy this. I'm going to put in just a print line to separate things. Paste this. Okay. And this time I'm going to create a shift supervisor. Number we don't care about. I can then print out that information. And try the set name. It's not enough though. Okay, I also have to, while I'm here, to test the accessors, I'll also have to do a set dot get salary. S dot get bonus. Okay. So let's say he goes by instead Anthony. We'll change his number, just we need to test it, so we're going to change it to something else. We have to further set the salary. And up here we had to set a salary, which we did. This takes that. Takes a salary, let's say he makes 40,000, 25 cents, bonus of 1,000, 23 cents. Okay. So I can set his salary now to, let's say, 42,000. And then do an S dot set bonus, 2,000, 8. And then, easier just to copy that. Okay. So now I'm testing everything. Okay, I'm testing the employee init, the employee get name, get number, the employee set name, set number, and the same thing for the shift supervisor. Oh, but I didn't change that. Is that what you're going to say?
Yeah.
Okay. Run this. Yeah, looks like it worked. Okay, so we had Alice, which we changed to Bob. We had Tony. We changed all of that information. It all didn't blow up, made all this changes. Okay. So keep in mind that what we're doing, these last two chapters, are not very useful as far as programs go, right? These are dumb programs, right? They don't do anything. You wouldn't do any of this stuff in reality, okay? So this is more like a modeling thing. We're getting ready to create our own custom data types. That's what we're doing, that we can use in other programs, okay, that we'll hopefully get to later in the semester. If not, you've got the building blocks later for more complex programs, okay? The next task is going to be heavy on this object-oriented stuff, okay? You'll have classes, you'll have the inheritance, you'll have to do the string functions, okay, all that. So the best thing you can do is do them so much that you're just tired of looking at it. That they're so easy and so straightforward, you don't have to think about it. Okay, that's when you're ready for the next test. Okay. Other questions on any of this stuff? Okay. Okay. See if you have any questions. I don't see anything in chat. I'm going to assume that's okay then. Okay. So that's all I've got. There is homework out there. It's problem 3. The only one we haven't done. Okay. And that's all there is in this chapter, but I will go back to chapter 10. And if you need more practice, do all those. If not, you can look around online and find others that work as well.